Okay, so here we are on question number 1. Find the inverse if it exists. So you just have to put matrix A into your calculator, well, that matrix right there, and then hit the inverse button, and when you do, you will get answer B. All right, next question. Okay, question number 2. Mark and Kate are establishing a fund for their son's college education. What lump sum must they deposit? Okay, so the key in these questions to figuring out which of those 4 formulas, so we're looking back at these 4 formulas right here, 1, 2, 3, 4, should we use? Well, the key is, first off, the first question you want to ask yourself, question 1, is it one trip to the bank? If so, it's compound interest formula, or is it many trips to the bank? If so, it's annuity. So what is this one? Number 2 here. What lump sum is to deposit in order for them to have $65,000 at the end of 10 years? What lump sum? So that's one trip to the bank, right? So it's one trip to the bank. So we go back and grab the compound interest formula, this one. So it's A equals P 1 plus R over N to the NT. What's the P? What's the principal? You have 65,000. The amount is the 65,000, isn't it? They want to have 65,000, so that goes out here, and the principal, is what they're trying to find. Okay, and the interest rate is 6%. The N is how often it's compounded monthly, so that means N is 12, and the time is 10 years. So there we go. You just solve that formula for P, and use your calculator to do that. And the P will turn out to be answer D there. All right, let's move on. So number 11. Okay, so this is a big problem here. Always put the variables on the top. So I'm going to go X, Y, Z. How do you know that's variables? Because that's all my answers are, X, Y, and Z. So my variables. And what are the things we're talking about? Electronics and assembly and quality assurance time. So let's put the numbers in there. They go with those. 3.2 hours of electronics, 2.8 of assembly, 4.4 for quality, and then 3.4 for Y, it's 3.4, 3.8, 3.2, and then Z, it's 4.8, 5.2, 3.4, and then it says the totals for 356 for electronics, that goes over here because that's electronics, and then what is it, 358 for assembly, and 364 for quality. So basically just put that in as a big old matrix and do RREF on your calculator, and the answer will be D. 45, 20, 30. There we go. Let's go to number 12. So number 12, Linda invests 25,000. Okay, so it's another one of these investment problems. So, so on these investment ones, what are our variables on this thing? Our variables are the amount of 5%, 6%, and 8%. So I'll put that right at the top. Amount of, start with 5, huh? The amount of 5%, 6%, and 8%. Okay, well, 25,000 is the total. So you always have total invested. So that'll just be x plus y plus z is 25,000. And then you have what they earn. The earn will always have the percentages. So 0.05x, 0.06y, and 0.08z. That's what they actually earn. 5%, 6%, and 8%. And then what else is going on there? So, oh, and that was the total 1,600, wasn't it? That was the earning. And then finally, the third equation, which is always the most tricky. So, do you see that then? So the total, you just x plus y plus z is total. The earnings is, it always has the percentages involved because that's how you earn a percentage of the investment. And then finally, the amount invested at 5%, it says here, is double the amount at 6%. Remember how we talked about that? Whichever one, I want to make them equal. I want to write an equation, bring equality. So if you want to make two things equal, then you got to bring up the little guy, right? So if I tell you somebody's twice as big, then you got to double the other guy to make them equal. It's telling me the 5% is double, is twice as big. That's x. 5% is the x. So x already is twice as big as the 6%, as the y. So I got to double the y to make x equal to 2y, because x already is twice as big. So double the little guy, double the y. That's my equation. But you have to get x's and y's and z's on the left, so bring the 2y over, so that'll become x minus 2y plus 0z is 0. That's the third equation. So your matrix will end up being 1, 1, 1, 1, 1, 1, 25,000, and 0.05, 0.06, 0.08, 1,600, and the last one, 1, negative 2, 0, 0. Put that in, RREF. Get your answers on that one. It'll be D again. A lot of D's here. On we go. Number 13 is going to be basically what we have here is Barney was charged. So for Barney, it was $108, 3 days and 300 miles, and that's $108 for Barney. Mary, 192 for Mary. This will be the Mary equation. The other one was the Barney. The Mary equation, 192, 5 days and 600 miles. So these rentals, basically they have a daily charge and a mileage charge. So however much this rental charges per day times 3 days, how much per mile times 300 miles came out to be 108 for Barney. However much the daily charge times 5 days and the mileage charge times 600 miles came out to 192 cost for Mary. So what does that mean? So that means make it a matrix, 3, 300, 108, 5, 600, 192. Do the RREF on that one and get your answer. Lo and behold, it's D again, because the answer will come out, the rental charge per day will come out 24, and I don't know what the second answer is, but it's D on the top and M on the bottom, because D comes first and then M. So the D answer, the daily charge answer, they want the 24. On we go. Okay, so there's A and B, and they want me to do that. So that's just, I'll use your graphing calculator and put matrix A and B in there and crank it out. You'll get answer C. Let's go on to number 15. Find the interest rate needed. Number 15. For $38,000 to be accumulated in 5 years if 65 is invested at the end of each quarter. So that means it's an annuity, right? It's an annuity. It's being done several times, not just once. Is the pile, the big pile, now or later? Future value, later, or now, present value? Which one is it? Find the interest rate needed for $38,000 to be accumulated in 5 years. That's the pile later, right? So later, that's future. Future value. So that's the one we have two kinds at the end of each quarter. So that's ordinary, because it's at the end. It's not annuity due. That's when you pay at the beginning of each period. We'll get to one of those in a minute. At the end of each quarter, ordinary. So future value of ordinary, annuity. Future value, ordinary, annuity. So let's write that formula. I'm going to bring it up here. S equals R over N to the NT minus 1 over R over N, like that. Okay. Now what are they giving me? They're giving me 38,000 to be accumulated, so that's the S. 38,000. R is 1675. 1 plus little r is what we're trying to find. Each quarter, so that's 4. N is 4. Getting a little scribbly there. To the NT, 4 times T, 5 years, over R over 4. Okay, so there we are. We're supposed to solve that equation for the R. Now, that's super tricky. No way to do that other than the graphing calculator. So you're going to have to do this one on your graphing calculator. What do I mean by that? Let me get this out of the way and explain a little bit. You're going to have to let Y1 be the left side, 38,000. You're going to have to let Y2, you're going to let this be an X and this be an X, so it'll be 1675. Now let me do 2 layers of parentheses. Parenthesis, and then inner parentheses. 1 plus X divided by 4, parenthesis, to the 20th, right? This is 20 right here. Minus 1, and then you got another parenthesis there. Now, I like to grab this denominator right here. I think it'd be easiest just to grab this and flip it up, make it 4, make it multiply. Right, when you divide by a fraction, you can flip it upside down and multiply by it. So times 4 divided by X. So that's Y2. So now you've got to graph that. When you graph it, you'll have to check the Y max by looking at second table to see how high up it goes. And you'll see that you need your Y max to be something like, I don't know, maybe 50,000, because the values are going very high. So you'll need to make it maybe 50,000 for your Y max. And the other trick on this one is your X min will have to be 0 and X max will have to be 1. Why? Because the X values, remember, X is in the rule of rate. Rate is a decimal. So it'll be between 0 and 1. So if you graph that and then find out where they intersect, you'll be able to get your answer on that. So let me do that on my calculator. Okay, so when I did it on my calculator, I got X is 0.0522 223, which, move it 2 places, is 5.223%. 5.223, so it's not quite here, it's none of the above, 5.223%. That's a very hard problem. Let's move on. Okay, we're on to number 16. 6% compounded daily. So this is APY. What do you do on an APY? That means find the actual annual percentage yield, which means what the interest rate really does. 6%, if you do it daily, it'll actually do a little better than 6%. The more frequently you compound, the higher it actually comes out. So 6% done daily will come out a little higher. How do you figure that out? Make sure you have in your 3x5 card, for APY, there'll be one APY question. You let P be $1, T be 1 year, and then take your answer and subtract the $1 original back out. That's how you do it. So, and we're always using the compound interest formula, because we're not making several payments here, right? We're just saying, putting money in once, what'll happen? A equals P, 1 plus R over N to the NT, so put in $1 for P, and the interest rate were 0.06, whoops. N is 365 compoundings per year. The time, 1 year. And there we go. Let's crank that out. So 1 plus 0.065 divided by 365 to the power 365. So I'm getting 1.06183. So you subtract out the original dollar, because that means $1 became $1.06183. So the gain was this. Turn it back into a percentage, move it 2 places, 6.183. That's the actual effect of this account. It makes your money grow like that. So that's, again, none of the above on that answer. So that's how you find annual percentage yield. All right, number 17, it's just A times B. That's just use your calculator, enter matrix A, enter B, and multiply them. You will get answer B. Number 18, compound amount for the deposit. So we're putting in money one time. So, right, this is just one time. There's nothing about regular payments here. To the NT, the P, find the compound amount for the deposit. We're putting in 140,000, and the interest rate is 0.0147. Quarterly, so N is 4, 5 years. So crank that out on your calculator, you'll get answer D. Let's go to number 19. Number 19 is basically make it a big matrix. 3 minus 5/7, 10. 2/3 minus 9/7, 19/5. Do RREF on it, and you'll get this answer for Y. Let's move on. Okay, so number 20. So this is X, this is Y, this is Z, this is W. This is an RREF, reduced row echelon form answer. So what you got to remember for that is the first column is X, then Y, then Z, then W. So what does that mean then? What is this first line saying? X, right, 1X. Plus 3W equals 13. What is the second one saying? Y, because 1Y, equals -9. What is the third one saying? Z, minus 2W equals 4. The last one's saying 0 equals 0, which is a silly thing to say. That's true, but it's not helpful, so we ignore it. All right, so then basically we solve the first three equations for X, Y, and Z. So move this over. So X will be 13 minus 3W. Y will be minus 9. Nothing to do there for Y. And Z, getting Z alone, moving the 2W to the other side for plus 2W on that. So then we look for that answer, and we see it here on B. 13 minus 3W, minus 9, and 4 plus 2W. Let's go on to 21. So 21, you basically put this thing in your calculator. 220 minus 4 minus 3, 20 minus 3 minus 5, and you put the minus 4 minus 1 minus 10 in the right side. You just stick this in the right side and hit RREF. You'll get your answer A. That's it. All right, so question 3 now. Bob deposits $5,000 at the end of each year. So that's an annuity because that's many deposits or withdrawals. Right? That's many trips to the bank. That's not just one trip to the bank. So that's always an annuity. Annuity is a series of deposits or withdrawals. So it's an annuity. So there's 3 annuity formulas if we go back here. 3 annuity, this one, this one, this one. How do we know which one we're supposed to use? Well, it's all about, next question, is the big pile now, which would be present, value or future value? So big pile now or later? Let's see. Bob deposits $5,000 in 14 years. Da 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 da. Find the amount he will have. The amount he will have. That's future. This is a future value problem. So it's an annuity, future value. Let's go back. So future value. We have two kinds: ordinary and annuity due. Two kinds of future value. It's this other one's present value. That's not ours. That'll be some other problems. Okay, so which one is it? Well, the difference now, so we know it's a present value. I'm sorry, it's a future value. So it's future value annuity. Now there's two kinds. We have the ordinary, which means that you do at the end of each period, and we have annuity due, which is you deposit at the start of each period. So what is this one? End of each period or start of each period? It says at the end of each year. So this is ordinary. So future value, ordinary. Future value, ordinary. All right, let me get a fresh screen for us. So future value, so it's an annuity, future value, ordinary. See how I came up with that formula? I mean, with figuring out which formula. Now let's go back and grab it. So we'll use the future value, ordinary annuity formula, and that is S equals R, 1 plus R over N to the NT minus 1 over R over N. Okay, so what did they give us? He deposits $5,000. That's the payments he's making. That's your R. The little r is 6%. The N, what is the N? Each year. So N is once per year. N is the number of times per year, so that's just once per year. And it's 14 years over 0.06 over 1. There we go. Hit the buttons on your calculator for number 3 and you'll get answer A. Let's keep moving. So number 14, it basically says that they want averages. So for Herd, 12 points on Friday's game. Saturday's game, 10 points for Herd. What's the average of 12 and 10? You add them and divide by 2, right? 22 over 2, 11. That's the average of 12 and 10. That's right in the middle of 12 and 10. And that's what they have right here. So it's looking good. How about, let's try for rebounds. 13 and 11. 13 plus 11 divided by 2. 24 over 2. 12 is the average. It's right in the middle of 11 and 13. 12. Yeah, that's looking good. If you keep checking, A is the answer there. It is the averages for those things. So let's move on. Okay, so you want to put on your 3x5 card for number 5 when you see input-output matrix. The way you do that is I minus A inverse times the D matrix. No. What are these things? The I matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. And we're going to actually call that matrix B. Let's just put that in matrix B. A is this matrix. And the D matrix, what's the D matrix? That's 9, it's right here. Demand of 900 for each. 900, 900, 900, right? There's 3. It's manufacturing and agricultural and transportation. And they're all 900. So basically put this in matrix B. This is matrix A. And this is matrix D. Store them in your calculator and then type in, parentheses are important, B, which represents I, it's the I matrix, which is the identity matrix, minus the A, we have parentheses here, hit inverse times the D matrix, and hit enter, and you'll get your answer on that, and it'll be answer D. All right, number 6. So on this number 6, it's tricky because we're supposed to see which matrix multiplication is going to be the right one for what they're trying to say. Well, if you look at it, they're saying school A is 90, 20, and 80. See how this is 90, 20, and 80. And 60, 20, and 20. 60, 20, and 20. And 80, 170. 80, 170. And the costs are 15, 20, 25. 15, 20, 25. It looks good. But also, B looks good. They just, instead of 90, 20, 80, they put the 90, 20, 80 sideways. Then the 60, 20, 20 sideways, and the 80, 170 sideways. And this is the same. Well, how do you know if it's A? C and D don't have all the numbers, so they're not right. So it's either A or B that have all the numbers. Well, how do you know whether it's A or whether it's B? Well, you got to know something about how matrices multiply. When you type matrices into your calculator and have it multiply, the matrix on the left goes left, like this guy first, this guy second, this guy third. And the matrix on the right goes down, this guy first, this guy second, this guy third. So you got to know how they work. That's what calculators do when they multiply matrices, or computers. So what? Okay, well, see if that's right. Now, do you want 15 multiplying 90? Because that's what it'll do. That's the first thing it'll do. Is that a reasonable thing to do? Yes, it is. Because what is 15? What is 90 is the 90 is book 1. That's how many book 1s. And 15, what's that? That's the cost of book 1. Cost of book 1 is 15. So 90 copies of book 1 times $15 a copy. That's perfect. But, of course, this matrix, matrix B, also goes across and down, and it starts with 15 times 90 also. So far, so good. So we got to look at this. They're equal. Let's look at the second entry and see what they do there. Next, 20 will multiply 20. Versus this guy, 20 will multiply 60. See how? Here's where they'll be different. Which one's right? Do you want 20 multiplying 20? Or do you want 20 times 20? Is that a reasonable thing? Or do you want 20 times 60? Which one of those is a reasonable thing to do? Well, look up at the words, and the words will tell you. Let's try to find the 20. Let's see, where's the 20? 20 is how many book 2s? And book 2 is $20 each, so that's right. 20 book 2s times $20 each. We do not want 20 multiplying 60. Why not? What is that? 20 is how many book 2s? 60 is how many book 1s? Why would you want 20 multiplying 60? That's crazy. A, that setup is multiplying the right things. A is the way you want to set it up. Let's go on to number 7. In order to purchase a home, family borrows $50,000. Okay, so let me help with that. Here, let me get a fresh screen on that. Okay, so all of the home or car purchases, those are always going to be present value of an annuity. Because why present value? First of all, it's annuity because you're making payments, right? 20-year period, equal monthly payments. That's an annuity. Present value because you get the house or the car now, right? You pay, the bank pays the car maker or the house maker for your house or car right now. So it's present value. You have it now. You're not saving up for the house later. You have the house now or the car now. So those are always present value. So let's see. Family, so that means I'm going to use the present value formula. So that's P equals R, 1 minus 1 plus R over N to the minus NT over R over N. Like that. Okay, and so in order to purchase home, family borrows $50,000. So, that's the amount. That's the principal they borrowed, $50,000. We're going to find the payments. And 1 minus 1 plus, and our interest rate is 12%. It's monthly payments. That's N is 12, right? Monthly. N is the number of times per year. And to the minus 12. And what is T? How many years? 20 years over 0.12 over 12. So there we go. So you got to solve that equation for R, which means you have to divide by that whole chunk on both sides, canceling it out, solving for R. It's 50,000 over that whole chunk to do that. And so when you do that, you should get the answer D there, 550.54. So number 8, least amount that could be deposited in a bank account today at 12%. So in order to allow compounded quarterly, to allow 650 withdrawals, so it's several withdrawals, right? Several, so it's an annuity again because it's several withdrawals, several withdrawals. So that's annuity. Compound interest is just once, so it's an annuity, several withdrawals. Is the big pile now or is the big pile later? What does it say? Find the least amount that could be deposited in a bank account today. The pile is today, so it's present value. So it's annuity, present value of an annuity, and so that's our formula. So it's P. It's gonna be the same as the last one. Right, so I'll just move on from that one. The answer to that, so you just use the present value of an annuity formula. And your answer on that one will be, it's none of the above, huh? So maybe I better show that. So present value annuity, so it's P equals R, 1 minus 1 plus R over N to the minus NT over R over N. Like that. Okay. So what does it say? The 650. Those are the withdrawals. The month. The R, and the big R, and the little R is 12%. It's monthly, right? Isn't it? Oh, quarterly. Quarterly. So N is 4, and time is 9 years. Like that. There we go. So type that into your calculator. I'm going to do it right now too. Let's see what we get. So now let me help with how I type this in. Remember how I type this in? I start right in here and I go 1 plus 0.12 divided by 4, hit enter. Then I've got this. Now this is minus 36, isn't it? So then I go to the power minus 36, enter. Then I go 1 minus answer, enter. And then here's the real trick. Divide by, you got to put parentheses around that denominator when you divide by more than one thing in a denominator. Hit enter. And then bring it up here, times the 650 in the front. Hit enter. That should lead us through it. Let's see what we get. I'm getting 14190.96, 14,190.96, and that's none of the above on that. Okay, there we go. Number 9, Larry wants to start an IRA that will have 810,000. That's future. So that's retirement. That's future value of an annuity, isn't it? Future value of an annuity. So the question is he putting the money in the start or the end? At the end of end of each period. So that's ordinary. If you're putting it at the beginning of each period, that would be annuity due at the beginning. But this one's at the end, it's ordinary. So we grab that formula. So that formula is S equals R, 1 plus R over N to the NT minus 1 over R over N. That's the future value, ordinary annuity. All right. He wants to start an IRA. So that one's normal. I'm gonna go ... on that one. The answer is A. 810,000 is what he wants. It goes right there. And right, so 810,000 goes right there. The R is what we're looking for. How much he should invest. Yeah. And the N, 6 months, is 2 because of 6 months, twice a year. The little r is 0.08. The time is 19 years. It comes out answer A. All right, let's move on. All right, find the interest rate. So that makes statement true. So 9,000 grows to 15,813.95 in 8 years. So that's not an annuity. That's a one-time. You put 9,000 in the bank and it grows. Not several trips to the bank. One time to the bank. It's a compound interest formula. It's not an annuity. So we use A is P, 1 plus R over N to the NT. All right, so let's figure it out. So you want 9,000 to gross to be 15,813.95. 9,000 is the principal. The interest rate we're trying to figure out. The N, it says annual compounding. That means N is once a year. The time is 8 years. Yeah. So we're supposed to solve for the interest rate there. Okay, so what do we get? How do we solve that? Well, to solve that equation for R, I'm going to divide both sides by 9,000. Boom. So I get 15,813.95 over 9,000. 1 plus R to the 8th. Okay. Now how do we solve for R? We raise both sides to the 1/8 power. That's what will cancel out that 8. And you get 1 plus R is that, and then you just subtract the 1. So it'll be 15,813.95 over 9,000 to the, to the 1/8 minus 1. Subtract 1 from both sides, right? So there we go. Type that into your calculator, and you should get the answer D, 7.3%. Keep moving.